Geometry 8.5 Part 2 Notes. Make sure you're on page 31 of the packet. So today we're working on surface area of pyramids and cones. So just a little bit of vocabulary here. The vertex is the top of the pyramid, and there is only one point that makes up the vertex. The altitude height is going to be this length right here. So the height of the pyramid, how tall it is, there's just one altitude height. Slant height, that's going to be the side height. So the height of the triangle on the side, we'll need that measurement for surface area. So there would be 4 slant heights because each side has its own slant height. Slant height is going to be labeled by the letter L. L for slant height. Altitude height, that's going to be labeled by the letter H. All right, lateral faces, these are the sides, the triangles on the sides. So depending if it's how many sides it has of a pyramid, in ours there's 4 lateral faces. Each triangle is a lateral face. All right, just a little bit more vocabulary here. Base edge, this is going to be the side of the base. So in this case, there's 4 of those, depending if it was a rectangular pyramid or triangular pyramid or what. Base, there's always going to be only one base. This would be like whatever the bottom is. Square, rectangle, triangle, pentagon. The vertices, in our case, there are 4 vertices down here at the base. And then the lateral edge, this is going to be, so not the slant height, but the side of kind of the pyramid that goes from the top point down to the bottom corner. So in our case, there are 4 lateral edges. All right, so let's go ahead and look at the equation for surface area. Again, you don't have to use an equation. You could just find the area of all these triangles on the side and then add the area of the base. Or you can use the formula. All right, so surface area of a regular pyramid, surface area equals 1/2 times the perimeter times that slant height plus the area of the base. All right, so L is slant height. All right, again, L is slant height, P is the perimeter of the base, and B is the area of the base. All right, so let's try example 1 here. Find the surface area of the regular pyramid. So we're going to use that equation, surface area equals 1/2 perimeter times the slant height plus the area of the base. So let's go ahead and start filling in. What do we know? 1/2 times perimeter of the base. What we would do to find the perimeter of the base is if it's a regular pyramid, all these sides are going to be 5. So add those up. So 5 times 4, or 5 plus 5 plus 5 plus 5. Okay, and then times the slant height. Now this one, we are not given the slant height quite yet. We need to calculate the slant height. So let's just leave a blank there for a minute because the slant height is going to go from the top down to the side, like that. So let's see, we'll go times, we'll figure that out in a minute. And then plus the area of a base. Now we don't need to do 2 bases like we did for the prism because it doesn't have 2 squares in it. It only has the bottom square. There's no square on the top. So in our case, since it's a square, we can just take 5 times 5, or 5 squared. Okay, so now let's zoom in and figure out how we're going to find that slant height. So if you think of this triangle right here, think about all the sides that are on that triangle. Okay, so we know that the altitude is 10. And then we also know that half of the base is 2.5, but the whole way across is 5. So we have to cut it in half and just look at this part that's 2.5. And then what we're trying to do is find that L for slant height. So think about in a right triangle how we can find a missing side. We can do the Pythagorean theorem. So we can calculate a squared plus b squared equals c squared. So go ahead and do that on your calculator. Try to figure out what L is. You can leave it as a radical, or if you want to change it to a decimal, either way is fine. All right, so if we add those up and take the square root, square root of 106.25. So if we calculate that, 106.25, take the square root, should be about 10.31. So you can either leave it square root of 106.25 or 10.31 equals my slant height. So when I go back up to my equation, for my slant height, you can either leave it square root of 106.25 or just leave that number in your calculator, 10.31. All right, so now we need to calculate it. I'm going to simplify it a little bit first. So we have 1/2 times 20 times 10.31 plus 25. So 10 times 10.31 plus 25. You can type it all in your calculator. I'm just simplifying it a little bit as we go here. So if I pull up my calculator, I could take that original number I had, if you want to try to leave it as the best approximation, and take it times all this stuff over here. So times 20 times 1/2, and then plus 25. So the surface area should be about 128.08 or 128.1. Square meters. Okay, so that's one where you had to do that extra step. We had to figure out what is the slant height. All right, let's go to the next page. Now we're going to look at finding the surface area of a cone. So page 32. So think of a cone as like a sugar cone that you put ice cream in, or like a snow cone. Okay, so we can do this the same way, except for that it's circles as your base instead of squares and triangles and things like that. So to get the surface area of a cone, we can figure out that the base is a circle whose area is pi r squared, and perimeter is 2 pi r. So we can still use that same equation. I'm going to kind of derive it here. So on the front, we had 1/2 perimeter times slant height plus area of the base. So now I'm going to fill my circle information in. So I'm going to go 1/2 perimeter was 2 pi r. And then we still have that slant height plus area, pi r squared. So if we wanted to simplify that, those 2's can cancel. So when I do surface area of a cone, and remember all these formulas are in the back page of your packet, we're getting pi RL plus pi R squared. Okay, so that's the one that you want to have written down that you want to use when you're doing a cone. All right, so let's try number 4. So surface area pi RL plus pi R squared. And this is another one that you can leave in terms of pi. On our test, we're just going to round it to the nearest tenth. But if you want to write it in terms of pi as you go, that's fine. Okay, now notice we're missing our radius. But we do know the slant height. That's going to be this 15. The height would be 12. The slant height is 15. Plus pi, and we're missing our radius again, squared. So what we need to do is calculate our radius. So there we go again. We have another right triangle. We can use that Pythagorean theorem. A squared plus b squared equals c squared. Remember, you're going to put that hypotenuse always last as your c. All right, so go ahead and finish that up. I think this one comes out to be an even number here. So see if you guys can figure out what the radius is. So we get radius squared equals 81. And then we take the square root of both sides. And we get radius equals 9. All right, so everywhere I had a radius there, I'm going to put it 9 in. So pi RL plus pi R squared. And if you want to leave it in terms of pi, multiply everything but the pi's. So you can only do this first part and then the second part. So 9 times 15 would be 135 pi plus 9 squared, 81 pi. And then add those up. So we get 216 pi. Or if we multiply that out, then I would get 678.6 square centimeters. And again, we're back to square centimeters because we're working with surface area and not volume. Okay? All right, why don't you guys pause the video and try number 5. All right, so for example 5, your slant height is 12, your radius is 6. So just plug all that in. Should get surface area to be 108 pi in square feet. And then as an approximation, 339.3 square feet. Okay, so your assignment for today is to do page 33 and 34. Okay? Email me if you have any questions.